Hi dear students, this presentation is from the second module of the subject Advanced Energy Engineering. In the last presentation we were discussing about solar thermal electric systems. So we have discussed up to solar space heating devices. Now we will be discussing about solar space cooling in this presentation. So this is a schematic representation of the space cooling solar thermal system. So the ultimate purpose is to cool a particular space, whatever it may be. Usually it will be a room within a house, or it can be a large space, large area, or something like that is possible. So anyway, the ultimate requirement is to produce the cool air, so that once that cool air is circulated through the room where it is to be air conditioned, so that cool air will be absorbing the heat content within that room, so that the air becomes hot. That hot air is circulated back to convert it into again cool air. So during that process, the heat energy of this hot air coming from the room to be cooled is has to be absorbed by some other working fluid, some other fluid that is usually done by the refrigerant. So low temperature refrigerant will be absorbing the heat energy from the air coming from the room from the room where it is to be cooled. So usually that process is taking place within the evaporator. So in the evaporator, the low temperature, low pressure refrigerant will be absorbing the heat energy from the air, and it is converted into its vapor stage. So the latent heat of vaporization is absorbed by the refrigerant within the evaporator. That is what is usually taking place. So we need to provide low temperature, low pressure refrigerant to the evaporator to happen all these things. Okay, that is our aim. So usually solar space heat cooling can be done by two methods. One is using conventional vapor compression refrigeration system, and the other one is vapor absorption refrigeration system. So in the vapor compression refrigeration system that you might have studied well in that subject refrigeration. So in that system, a compressor will be there, compressor, condenser, expansion valve, then comes the evaporator. All these are the basic components. So in the compressor, the running power for the compressor, the electric power can be either directly produced by the photovoltaic cell and can be used to run the compressor. That is the simplest one. But in that system, solar energy conversion to electricity is there. So we cannot assure all the time electricity. So that is the difficulty. So mostly we will be depending on this vapor absorption solar cooling system. In this system, apart from the other one, we will be eliminating that compressor part. Compressor will be completely eliminated by a set of absorber tank as well as the generator. Okay, so this entire portion will replace the compressor system in the vapor compression system. That is what is known as vapor absorption system. So the rest of the part, that is condenser, expansion valve or throttling process, and evaporator, all these three components will remain as such in the case of vapor compression system also. Here also it is same. Okay, so only difference is in the left side part, this part. Okay, so coming to the working, anyway I am not explaining the vapor compression refrigeration system, that you have to study yourself. So I will be explaining vapor absorption system. This is the most commonly used solar space cooling system. So I will be explaining this one. So as a starting, we will start from the absorber. See, in the absorber tank we will have two liquids. One is absorbent and the other one is the refrigerant. Here most commonly the system used will be working on aqua ammonia system. In that system, aqua means water. Water is used as the absorbent and refrigerant is ammonia, and the other system is lithium bromide water system. In that, lithium bromide is used as the absorbent and water is being used as the refrigerant. So these two systems are commonly used, combination of water and ammonia. That is what is simply known as aqua ammonia absorption system. In that, absorbent is actually water and ammonia is the refrigerant. So ammonia will be passing through this cycle. See, this one is the cycle of ammonia, whereas absorbent will be passing within this closed circuit, that is from absorber to heat exchanger, from heat exchanger to back absorber. So that is the circulation, that is the flow circuit for the absorbent. So in aqua ammonia, talking about aqua ammonia, water is the absorbent and ammonia is the refrigeration. And in the case of lithium bromide, lithium bromide is the absorbent and water is the refrigerant. Okay, so refrigerant finally coming out from the evaporator will be in the vapor state at low pressure. So that low pressure vapor of the refrigerant will be coming to the absorber tank. within the absorber tank, initially the absorbent will be there, some fluid, absorbent fluid will be kept there. So this refrigerant will be mixing with the absorbent fluid, and as the name indicates, this refrigerant is completely absorbed or dissolved within this fluid. അങ്ങനെയുള്ള പ്രോപ്പർട്ടി ഉള്ള ഫ്ലൂയിഡ് മാത്രമേ ഈ കോമ്പിനേഷൻ ഉപയോഗിക്കണം. അങ്ങനെയുള്ളതാണ് അക്വ അമോണിയ. ഈ അമോണിയ വെള്ളത്തിൽ വന്ന് കംപ്ലീറ്റ് ആയിട്ട് ഡിസോൾവ് ആവും, മനസ്സിലായി, കംപ്ലീറ്റ് ആയിട്ട് അതിനെ അബ്സോർബ് ചെയ്തെടുക്കാൻ പറ്റും. അങ്ങനെയുള്ളത് മാത്രമാണ് അബ്സോർബൻ്റ് ആയിട്ട് യൂസ് ചെയ്യാൻ പറ്റുക. സോ ഇവിടുന്ന് വരുന്ന അമോണിയ എന്ത് ചെയ്യും, അമോണിയൻ്റെ വേപ്പർ ഇതിൽ മിക്സ് ആയിട്ട് എന്താവും, കംപ്ലീറ്റ് ഒരു സൊല്യൂഷൻ ഉണ്ടാവും. സോ ഇനീഷ്യലി ഇൻ ദ അബ്സോർബൻ ഓൺലി water was there. Once the refrigerant is added to this one, the solution, now it has become a solution. Initially only pure water was there, now it has become a solution of water and ammonia. So that solution, since ammonia content is there, that means strong content of ammonia is there, that means it is known as strong solution. That's why it is called strong solution. So in the absorbent, in the absorber tank, the absorbent will absorb the refrigerant and it becomes strong solution. That strong solution is pumped through a recuperator. I will explain what is the function of the recuperator. It is actually a heat exchanger. So through the recuperator, it is passed through the generator or heat exchanger. See, this is the heat exchanger or a generator. This is called the generator. So strong solution is passed to the generator. So within the generator, what happens is, see, the hot fluid from the solar collector at a very high temperature will be passed through the generator separately, so that it acts as a heat exchanger. So the heat from the hot water or hot fluid within the solar collector will be given to the strong solution. So once the strong solution absorbs the heat, the refrigerant solution with refrigerant added to this solution will vaporize. See, the absorbent is not getting vaporized, only the refrigerant is getting vaporized. So high pressure vapor of the refrigerant is formed at the generator, that is being used for the refrigeration cycle, that we will discuss later. Anyway, once at the generator, you absorbing the heat from the solar collector, the vapor is separated, refrigerant vapor is separated, that means the solution again becomes less content in refrigerant, that means weak solution. It is formed, is called a weak solution. അവിടെ എന്തുണ്ടാവില്ല, പിന്നെ ഇവിടെ അമോണിയൻ്റെ കണ്ടന്റ് ആഡ് ചെയ്തപ്പോൾ എന്തായി, അമോണിയൻ്റെ സ്ട്രോങ് സൊല്യൂഷൻ. ഇവിടെ എത്തിയപ്പോൾ എന്തായി, അമോണിയ എവാപ്പറേറ്റ് ചെയ്ത് പോയി. അപ്പോൾ ബാക്കി എന്തുണ്ടായാലും വെള്ളം മാത്രമേ ഉണ്ടായാലും. അപ്പോൾ എന്താണ്, അമോണിയൻ്റെ കണ്ടന്റ് വളരെ കുറച്ചേ ഉണ്ടായാലും. അപ്പോൾ വീക്ക് സൊല്യൂഷൻ എന്ന് പറയും. ഇവിടെ വരുമ്പോൾ അമോണിയ കൂടി വരുവാണ്, അപ്പോൾ അതിന് സ്ട്രോങ് സൊല്യൂഷൻ. സോ ദാറ്റ് വീക്ക് സൊല്യൂഷൻ formed after evaporation of the refrigerant will be passing again in the opposite direction through the recuperator, and then it is passing through the throttling valve and it is coming to the absorber. So this is the circulation of the absorbent. Okay, so only function of the absorbent is to absorb the refrigerant from the absorber, and it is passed to the generator where it is evaporated to produce the vapor. Okay, so this is what is so during passing through the recuperator, you can see here we are providing heat to separate the refrigerant from the strong solution. So if while passing, so after strong solution while passing through this recuperator will have a high temperature. The temperature is absorbed by the strong solution before passing through the generator, and by this way the heat required to be provided within the generator can be reduced. That is the advantage. That's why this recuperator is used. Without this also it will work, but more heat energy is to be provided by the fluid from the solar collector. See, the hot fluid from the solar collector will be entering into the generator in a separate coil. This is actually heat exchanger. There is no mixing of the strong solution with the fluid from the solar collector. So the heat energy from the fluid of the solar collector will be supplied to the strong solution within the generator. So the temperature of the fluid coming from the solar collector will be decreasing. That low temperature fluid is again circulated back to solar collector for absorbing more heat. So heat absorption is actually taking place here. So once heat is provided in the generator, low temperature fluid will be again circulated back through the collector. So this is collector fluid circuit. Okay, so I have already explained absorber generator system. Now coming to the refrigeration side, the high pressure refrigerant vapor formed in the generator is now passing through the condenser. So while passing through the condenser, it will give away its heat to the cold fluid, which is coolant, which is circulated through the condenser, so that its phase change will take place. See, it is in the vapor state, high pressure vapor state. Once it passes through the condenser, the refrigerant will become high pressure liquid refrigerant. So that high pressure liquid refrigerant will be then passing through the expansion valve, or this is what is known as throttling process. Once the high pressure liquid refrigerant passes through the expansion valve, what happens is throttling will take place. Throttling means the enthalpy will remain constant, whereas the pressure is changing from high pressure to low pressure, and correspondingly temperature also will be reduced to low temperature. So temperature conversion, high temperature to low temperature conversion is taking place in the expansion valve. So finally, after expansion in the expansion valve, we will have a low pressure, low temperature refrigerant still in the liquid state only. So that liquid state refrigerant will be passing through the evaporator. See, the actual refrigeration process is taking place at the evaporator. The warm air from the room where it is to be cooled is coming to the evaporator. So there is, just like here, there is no direct contact between the refrigerant as well as the air. It is actually a heat exchanger. Evaporator is actually again a heat exchanger. The low temperature liquid refrigerant will be flowing through a separate pipe, whereas the air will be flowing through another separate coil. So since air is at a higher temperature and the refrigerant is at a very low temperature liquid state, the heat from the air is absorbed by the refrigerant within the evaporator, so that it will be changing its phase from liquid state to vapor state. So just phase conversion is taking place. So that much energy is absorbed from the warm air coming from the room, so that the air is getting cooled. That cool air is again recirculated back to the room for the cooling purpose. That is what is happening. So this side we will have the cooling of the space cooling is taking place. Okay, so once it absorbs the heat, the refrigerant will be coming to the vapor state. A low pressure vapor refrigerant will be then passed on to the absorber. So within the absorber, it is again mixing with the absorbent to become strong solution. Strong solution is passed to the heat generator. This cycle is continuously happening. So this is the basic working of the solar space cooling system using vapor absorption system. Now those who are interested, they can study the space cooling system using vapor compression refrigeration system also. That is much simpler as compared to this one. But most of them are preferring vapor absorption system. The reason is, here low grade heat can be converted. Much heat is not required for this process to take place, but for producing electricity to run a compressor, we require a very high conversion of the solar energy into electricity. That is practically very difficult, and the availability also having some problem. That's why the people are mostly depending on vapor absorption solar cooling system. This seems to be very simple, but in practical it is very difficult to implement. Okay, this is all about the explanation that I have already explained to. Please go through the slides. Now the last system is solar thermal power generation. See, the power is generated from the solar thermal system. That is what is known as solar thermal power generation. So in order to have the power generation, we must be depending on a basic thermodynamic cycle. Usually always we will be using the Rankine cycle for the power generation. So Rankine cycle you might have studied in the thermodynamics. Rankine cycle will have the basic components like pump, boiler, turbine and condenser. This is the this side you can see here. This is the Rankine cycle. Here in the Rankine cycle, high pressure vapor is produced within the vapor generator or boiler. So within the boiler or vapor generator, high pressure vapor working fluid is produced. If it is water, steam is produced. Then that steam is passed through the turbine, or the vapor is passed through the turbine, so that it is expanded. While passing through the turbine, it is getting expanded, so the power is produced or work output is produced in the form of mechanical work, that is rotation of the shaft of the turbine that is connected to the generator. Then you can produce the electricity. So once it is expanded within the turbine, this will be passing through the condenser. So in the condenser, it is condensed using a separate coolant. So it is converted to, that vapor is converted to liquid state. Then liquid state is again circulated using a pump back to the vapor generator or the boiler. Okay, we will call it as, if it is steam based one, then instead of this one we will have a boiler. Here since solar energy is to be clubbed with this one, so we will be using a separate heat exchanger like structure, that is also known as vapor generator. So coming to the solar thermal power generation, solar thermal electric power plants generally use concentrated sunlight obtained through various mirror configuration to focus the sun energy to produce high temperature heat. See, different types of solar collectors are used to concentrate the solar energy, so that high temperature working fluid is produced within the solar collector. See, here we will have the high temperature working fluid produced that fluid is passed through or stored in a separate storage tank. See, within the storage tank, we will be storing that hot water, just like solar thermal water heater. It will be working, but the temperature of the fluid within the storage tank must be very high. So highly concentrated solar type collectors are mostly used. Even for the low power production purpose, we will be using the flat plate collectors also, or reflector type collectors also is being used. That depends on the power output that we are producing. So anyway, the hot fluid by absorbing the radiation energy is stored within the storage tank. So once we want to produce the power, we will be circulating that hot water through the vapor generator. You can see a circuit for the hot water circulation, hot fluid circulation through the vapor generator. So the heat energy of the fluid passing through this line will be given to the uh, working fluid of the Rankine cycle, which is passing through this line. So this working fluid of the Rankine cycle will absorb heat from this hot water or hot fluid, whatever it may be. Usually in the solar collector we will be using the water, so water will be passing, high temperature water will be passing through this line. So the heat is given to the working fluid. Usually this is no working fluid, will be just like refrigerant in the case of Rankine cycle we will be using. So it will get vaporized at this vapor generator portion. So by absorbing the heat from this hot water, the refrigerant or the refrigerant like substance passing through the turbine will be getting vaporized within the vapor generator. That's why the name is called, this portion is called vapor generator. Actually it is a heat exchanger. So since vapor of the fluid in the Rankine cycle is produced in this heat exchanger, that's why it is called vapor generator. So the vapor, once the vapor is formed, once the heat is given to the working fluid of the Rankine cycle, the temperature of the water will be getting low, that is being circulated back to the storage tank. Then it is pumped through the solar collector for the again absorbing the heat. This is the cycle for the solar collector working fluid, and this one is for the Rankine cycle working fluid. So in the Rankine cycle, the working fluid is vaporized at this portion, so that high pressurized vapor will be passing through the turbine. So within the turbine, the vapor will be expanding. Expanding means its pressure energy is converted into work output. So the shaft will be rotating. That shaft is connected to the generator to produce the electricity. So finally we will be getting the direct power generation. Okay, so after expansion, the vapor is passed through the condenser. In the condenser we will have a separate coolant will be passing as a heat exchanger. So the vapor will be giving its heat energy to the coolant passing through the condenser, so that the phase of the vapor will be changing from vapor to liquid state. So low temperature liquid will be again recirculated through the vapor generator using a pump. This is the basic working of the solar thermal power generation system. So always we will be using the Rankine cycle. In the left side we can have different types of collectors based on the requirement at this side. We will be using different types of collector. Low temperature, medium temperature and high temperature can be produced by using different types of collectors. Solar thermal power cycle can be broadly classified as low, medium and high temperature cycles based on the temperature generator inside the collector. So inside the collector, how much temperature is being produced, based on that we will be classifying it into low, medium and high temperature cycles. For low temperature cycle, flat plate collectors are usually used. For medium temperature cycles, parabolic trough bar dish collectors are commonly used, and for high temperature, of course, concentrating type is required. Out of that, the higher performance is with high temperature central tower technology with heliostat are commonly used. You just refer the textbook for this type of collectors. In that, this is again a high performance version of the concentrator type. Lot of heliostat plates will be there. From each heliostat plates, the solar energy is reflected to a particular focal point where the heating fluid is kept. Okay, that is the working of central tower technology. Okay, you just refer central tower technology for more details. So if you want a high power output, then we will be going for central, but the space requirement by using the central tower technology will be very high also. So that is only for the very high power production, just like power plants and all, we will be going for that system. For the domestic purpose, solar collector with reflectors will be sufficient. Okay, so that's all about the solar thermal electric systems. Now in the next presentation we will be discussing about the direct production of the electricity from the sunlight, that is photovoltaic system. So till now, bye.